Hello, everybody. My name is Davide. I'm a production engineer at Facebook, and we'll be talking about building community with CentOS Stream. Here's the agenda for today. We'll start with a quick introduction on how we use CentOS at Facebook in production. We'll talk about contributing upstream to CentOS and to other projects. We'll deep dive into the work we've been doing within the Hyperscale SIG. And finally, we'll close with a few words on how to get involved in these projects. Let's get started. Facebook has a lot of machines. We have millions of servers spread across several data centers in the world. All of these are physical machines, and all of these machines run CentOS. And I want to touch upon a few of the reasons why we run CentOS specifically. CentOS, of course, has stable releases, and stable releases are great because they give you a base that you can build the rest of your infrastructure upon. CentOS also has a binary compatibility guarantee promise. This is by far one of the most valuable features in the distribution. What this means is that you can take a box at any given point in time, run DNF upgrade on it, and you won't have to restart any of the running services on the system. Everything will keep working as it were. This effectively allows you to apply unattended updates to machines at scale, both regular updates and security updates. And this is especially valuable for the parts of the distribution that you aren't necessarily following closely internally. CentOS is also part of the Red Hat family, of course, and it has mature and fairly well understood tooling within the space. So projects like RPM and DNF, for examples, are things that are very easy to work with at this point. They work very well, and their communities are mature and easy to engage with. CentOS can also leverage the work that's happening within Fedora because it's part of the larger Fedora ecosystem. And for example, at Facebook, we use a lot of packages coming from Appel, which is the extra packages for enterprise Linux, packages that came from Fedora and were rebuilt for usage in CentOS or RHEL. And because of the close relationship with Fedora, we can also cherry pick changes from Fedora and packages and rebuild them from CentOS as needed. That's actually something we do quite a bit, especially for low-level packages and plumbing things. So if you think about packages like systemd, where we do a lot of development upstream, we don't necessarily want to be stuck on the version that was packaged in CentOS when the distribution was released. We want to be able to follow upstream more closely because we're doing all of our development work upstream. So in this case, what we do is that we make backports taken from the Fedora rawhide packaging, and we try to build them to minimize the amount of changes we have to make. And specifically, we try to gauge Facebook-specific changes with a macro to make it easier to then merge things back upstream as needed. Over the year, we published some of these backports on the GitHub repo, where you can find them now. And we found this approach works pretty well. We call this a fast-in layer, and we found that CentOS combined with this layer of packages gives us a stable distribution that can move as fast as we need it to. Now, packages aren't the only thing we deviate from upstream occasionally. We also make a few policy deviations here and there. By far, the main one here is that we don't run the CentOS stock kernel. We have a lot of engineers at Facebook that do kernel development directly upstream, and they want to be able to get their changes in production as well, to be able to test them and deploy them. Because they're working on Linus S3, it makes sense for us to run something closer to Linus S3 rather than the distribution kernel. We also tend to enable some features that the stock CentOS kernel doesn't enable by default. So for example, our system ship with Sigroup 2 enabled by default, and they ship with Btrfs as their root front system on Slash. These two changes specifically are because we want to leverage all the work that is happening within the resource control space. We also make a few changes to packages related to networking. We don't use NF tables. If you run CentOS, you'll know that IP tables switch to the NF tables backend in the distribution there. So we rebuild IP tables with the Lexi backend enabled. We also don't use Network Manager. We've been running networking with network scripts for several years at this point. So for now, we are continuing to use that instead of Network Manager. In the future, we're going to start evaluating alternatives to that because NetworkScript is getting pretty old at this point. Now, as I mentioned, we've been running CentOS for a while. I've been at Facebook since 2012. At the time, we were running CentOS 5, and we went through several major OS migrations. We went from 5 to 6, then 6 to 7, and more recently from CentOS Linux 7 to CentOS Stream 8. Every time we do a major OS upgrade, we wipe and re-image the machine. We do this both because CentOS doesn't really support in-place updates, but we also like the fact that we're wiping machines for this because it gives us the ability to couple other changes that we might need to with the OS upgrade. Because you're paving the machine, you're effectively getting a clean slate. So this is a great opportunity to deprecate features that you may not necessarily want to keep or to apply changes that may be disruptive. So for example, when we switched to 7 to 8, from 7 to 8, we changed the root file system from extended for to Btrfs. And that's obviously a change that requires reprovisioning, so it made sense to do it with the distribution update. The way these updates work in practice is that they leverage the general maintenance windows that hosts have, and we have internal tooling to handle them. So a prefix owner can say, I have these many machines, I know that I can take an outage on this percentage of machines, and then set the updates to effectively automatically walk through all of their systems until they're updated. Now, we don't do reprovisioning for all updates, of course. For minor updates, we just do what you think is a reasonable thing to do, which is just run the NF upgrade. Specifically, we do this via a process we call rolling OS updates, where every couple of weeks, we take a copy of the latest repos upstream and we snapshot it. And then we roll out the snapshot across 2 weeks. And we do this via the config management system, which for us is Chef, where we run effectively the NF upgrade after doing some sanity checking. We have monitoring and tooling so we can check on the status of this update and stop things if the need arises. We also have the ability to apply quirks for specific packages as needed. Now, as I mentioned, we've been doing this for a while. And while we found this approach worked pretty well for Facebook, there's also some definite shortcomings here that we wanted to address. On the FTL front, as I mentioned, we have a number of backports of packages, and effectively these are forks. Like when we backport a package, we copy the packaging for rawhide internally, and then we build it and make changes. And for packages that we follow closely, like systemd, we try to do a good job at keeping it in sync with the upstream work and upstream changes. This isn't necessarily true for all packages. There's lots of examples where an engineer needed some fringe package updated, so they imported it, and that was kind of it. And then a year or so later, we find out that, oh, this package has some bugs, and they've already been fixed upstream, but we've been pinned on an older version because nobody ever updated it. At the same time, we found occasionally that we would fix bugs internally and forget to submit them upstream, and then it would get rediscovered a few years afterwards. On the policy deviation front, obviously these are deviations, so there are things we have to maintain long term. And that has a cost in itself, but it also has a cost in terms of making it harder to interact with the community at large. If I encounter a bug and I have to build a repo for the upstream environment is going to be different. My repo may not necessarily apply, and this is generally going to waste time for everybody involved. We also don't really have any kind of feedback loop to allow people to discuss why we're making certain changes and maybe try and figure out why upstream is doing things differently. Now, the answer for fixing all of these problems is, of course, to engage more closely with upstream. And this is what we've been trying to do across the years and what I want to primarily talk about here. Engaging with upstream is important because upstream is where the work is actually happening. The community is what is setting the direction here. The community is where all the work within the operating system is happening. Large companies like Facebook pride on the fact that they tend to move very quickly, but the reality is that in this space, it's the open source world that tends to move a lot faster and tends to adopt new technologies as soon as they become available. Because of these, oftentimes we'll find that problems and issues we've encountered internally have already been addressed in the community, and we can leverage solutions that we built there. At the same time, when we can contribute our work upstream, then we become co-maintainers of it. Other people can share in the maintenance of the work, they can make it better, they can extend it. All of these are things that are extremely valuable for the community and for the company as well. As for how you do this in practice, in my experience, by far the best way to do this is to just show up to the relevant communities and start engaging. Join the IRC channels, join the mailing list, go to conferences when you can go to conferences in person again, and just start talking to people and try to understand what problems they have, why they're doing things a certain way, and if you can, offer solutions and solve problems. If you start doing work in a community as a peer, as a member of the community, and you're solving problems there, then eventually people will understand that you're there to help, and they'll start maybe engaging you in things and asking you questions, and you're able to build a relationship with them. And then you can use this relationship down the road to better understand how things are working there. We found this approach worked very well in several communities we've been engaged with CentOS, with the chef community and with other projects we do work with. I don't think this is anything earth-shattering, but I wanted to say it out loud because I think it is important that you can't really expect to be able to engage with communities unless you're willing to commit to actually doing work there. Now, how does this work specifically with CentOS? To better understand that, I want to go back to when CentOS Linux 7 was released and go over how the distribution was built. So back in the day, Red Hat took Fedora 19, which was the current Fedora release at the time, and branched it. They branched it into another distribution, which is an internal distribution within Red Hat. And this distribution initially acts as kind of a primordial soup that is used to stabilize Fedora and morph it into something closer to RHEL. As time progresses and this distribution gets more stable and more and more components are adapted for what they should be, Red Hat puts in place various gatings and automated testing features so that at some point, every change that goes into the staging distribution has to go through testing and gating pipelines before it makes it to the final version. When this distribution is stable enough, it gets released as Red Hat Enterprise Linux, the commercial product that Red Hat sells. Then, once RHEL is out, its sources are used to rebuild CentOS Linux and release CentOS Linux 7 in the open. And this process iterates and keeps happening for point releases as well. Now, let's say you're running CentOS Linux at this point, and you found a bug. Let's say you found a bug in a fringe package, and you decide you want to make a PR and contribute the fix upstream, because it would be nice not to have to maintain a forked version of it internally. What are your options here? Well, okay, you could try to contribute to CentOS directly, but in this world, CentOS is just a rebuild of RHEL. There aren't any project that you can contribute to directly within CentOS here. You can't really contribute a fix there because there isn't anything that's directly in CentOS to fix. So, okay, if the upstream is RHEL, you could try contributing to RHEL. And while you can certainly find a bug for RHEL on bugs.redhat.com, you're unlikely to be able to get your change in a meaningful amount of time there. RHEL is a commercial product. Changes have to be justified based on business constraints. Especially if you're talking about a frame package, you're unlikely to be able to get a change in to fix a side problem that maybe you're the only one hitting. All right, so you're kind of stuck at this point because you clearly cannot contribute to the staging distribution. So the only option you have left is contributing to Fedora. And while you can certainly do that, that isn't going to help you if you're running CentOS Linux 7 now, because changes to Fedora will end up affecting the next major release. So what you end up doing in this scenario is what we ended up doing, which is you end up maintaining a lot of packages internally, effectively as forks or backports with fixes you develop over the years. And then when the next major release comes across, you try to reset state and check if any of these changes have made it to the new one. Now, things changed a bit with 8. If you've been following the news, the big change with 8 was were two announcements: the release of CentOS Stream 8 and the deprecation of CentOS Linux. And let's see how this works in the wider scheme of things. When 8 was released, they took Fedora 28 and they branched it again into this staging distribution. The difference here is that they actually released the staging distribution after the fact. So CentOS Stream 8 is the final version of the staging distribution. The final version with all the gating and testing in place, to be clear. So any change that makes it into CentOS Stream doesn't actually make it to the distribution until it's been through the same gating and testing it went through before to be able to get into RHEL. Then from Stream, RHEL 8 is released. And then from the sources of RHEL 8, CentOS Linux 8 is released in the same way as it was before. Now, in this world, if you want to contribute a fix, you actually have better options. Because while you still cannot contribute to CentOS Linux, and actually in this world, CentOS Linux is effectively going to go away after, I think, 8.5 or 8.6. I don't remember which one is the last point release. You can definitely contribute to CentOS. You can contribute to CentOS Stream specifically because CentOS Stream is an open project now. So you can send PRs to Stream, you can have them merged, and they will end up affecting the next RHEL point release, which is useful if you're running RHEL, but they also end up affecting Stream directly, which is very useful if your Stream is what you're actually running, like in our case. Now, with the 8 release cycle, I think this workflow is still being in flux quite a bit, and there's been a lot of changes. I think it's a lot more clear if you look at what it will look like for 9. 9 has been branched from Fedora 34. Fedora 34 was released the other month, and the difference here is that not only the tail end of the staging distribution is released as CentOS Stream, but also the initial side of it is released as part of Fedora ELN. So in this flow, you take Fedora 34. Fedora 34 is continuously rebuilt into Fedora ELN. And Fedora ELN is effectively a rebuild of Fedora, but with CentOS macros enabled. So it gives you a view into what CentOS would look like if it were branching today. Then, when it's release time, ELN is branched into CentOS Stream 9, and then the distribution is developed within CentOS Stream 9 in the open. This is where we're at now. Next year, when Stream 9 will be stable enough, it will be declared as stable, and RHEL 9 will be released. In the 9 cycle, there isn't a CentOS Linux anymore, so the only CentOS deliverable here is CentOS Stream. Oh, and I should say, in this scenario, obviously, your avenues for contribution are even better, because not only you can contribute to CentOS Stream directly, but you can also contribute to ELN. And I'll touch upon this in a little bit as well. So to recap, Fedora is what influences the next CentOS Stream major releases. What can you do in Fedora? Well, Fedora is a distribution, is a Linux distribution in itself. You can file and fix bugs, you can maintain packages, and you can drive changes. Driving changes is by far the best way to effect change onto the distribution itself and to effect change that will eventually make it into CentOS down the road. Over the years, we've worked with several of our community partners on sponsoring change proposals into Fedora. For the 3 cycles, we were part of the effort to try and get the root file system switched over to Btrfs by default, which was successful. For Fedora 34, we enabled Btrfs compression using the standard by default, and we also rolled out systemd UUMD as a replacement for early UUM. For the 35 cycle, which is currently in progress, we're working on enabling copy on write for DNF and RPM, which should speed up packaging installs quite a bit. We are also working with the cloud team on switching the default file system for Fedora Cloud to Btrfs. And finally, we're putting together a proposal to enable FSVerity support for RPM. These are all things that aren't going to affect CentOS now directly, but they will affect it down the road for the next releases. And Fedora is by far the best place to do this kind of wide-ranging work. Now, Fedora, as I mentioned before, also has a PEL as part of the project. And the PEL is additional packages that are taken from Fedora and rebuilt for RHEL as CentOS. Within a PEL, most of our work is within the PEL packager SIG. The goal of the packager SIG is to make it easier to add packages to a PEL. Over the years, we found that in a lot of cases, packages that people want to run are already available in Fedora, and they just haven't been built for a PEL. And the process to build and add them to a PEL is usually pretty straightforward. So most of the work we've been doing here is trying to improve the tooling and make it easier for people to add packages to a PEL if they want to, and also to set up a collective maintenance structure, so that for maintainers that don't necessarily want to maintain their packages in a PEL closely, they have an option to delegate that to another group. ELN, as I mentioned, is the continuous rebuild of rawhide using the CentOS macros. So at any point in time, it's a snapshot of what CentOS will look like, and it's what is used to bring up the next CentOS major release. Within ELN, most of our work happens in the ELN SIG. The goal of the SIG is to make it easier for ELN to be consumed. We're focusing there on making the distribution more easy to mirror. We're also working on extending the covers via ELN Extra. You can follow the work on the GitHub repo. Within Facebook, what we would like to do is build a continuous testing pipeline on top of ELN. Because ELN gives you a snapshot of the next CentOS Stream major release, if you keep testing onto ELN, you can find issues long before they will make it to a CentOS Stream release. We hope that this will make it easier to find and fix bugs before they make it to production, and it should result in a better product, both upstream for Fedora and CentOS, and downstream internally for us. The other thing that we think this will be helpful with is to identify policy changes early on. There's a lot of work that happens in Fedora that sometimes can be easy to miss. And if we can actually test and consume these deliverables early, we can find these changes early on and plan for them. And sometimes the planning would be adapting internally, and sometimes the planning would be engaging with the people that worked on the change upstream to better understand why they're doing things a certain way. Then, of course, you can contribute to CentOS. And right now, you can contribute to CentOS Stream 8. CentOS Stream is the continuously delivered distribution that tracks the next minor release of RHEL. Within CentOS, you can file bugs, obviously. And I put there how to file bugs because it's not obvious. Because if you go on Bugzilla, you will have to file bugs under RHEL 8 and other versions of CentOS Stream. The development for CentOS is in the open. And if you go on git.centos, you can see the branches for all the packages. You can send pull requests if you'd like. And you can generally follow the development of the distribution there. The other thing you can do with this CentOS is drive change via special interest groups. And SIGs are basically the building blocks of the CentOS communities. SIGs are where work happens both on the distribution itself and on areas where teams collaborate on special features, things like storage or networking. And anybody can found a SIG and do work in this space. So that's kind of what we ended up doing here. And I want to spend the last part of this talk talking about the work we've been doing within the Hyperscale SIG. Now, Hyperscale is a SIG that is focused entirely on CentOS Stream. And the goal is to make it easier for companies to collaborate on large-scale infrastructure deployment. Pretty much every company that deploys CentOS at scale ends up building more or less the same infrastructure internally, like infrastructure for snapshotting repos, infrastructure for building packages. And they end up maintaining a lot of the same packages. The idea here is to try to bring as much as possible of this development that tends to happen in-house behind closed doors out in the open, both so that we can have tools that everybody else can use, but also so that we can make the distribution better through this work and also make the deliverables consumable to everybody else. While the members right now are primarily large companies, this is absolutely not gated to large companies. This SIG is open to anybody that wants to work in the space. And if you're interested in joining, you should look at the wiki page. We hang out on Libera in /CentOS Hyperscale. So you're welcome to stop by there and ask questions if you'd like. Most of us are on Pacific time there, for what it's worth. So what are we doing right now in the SIG? The main thing we're building is an infrastructure for having faster moving backports of distribution packages. The idea is to take the packages that I mentioned before that at Facebook sit in this FPL layer into the distribution itself. So these are packages that tend to track upstream development very closely. They tend to enable extra features, but they also are meant to be drop-in replacement for the distribution packages. They should be usable directly and they shouldn't cause any regressions. They're meant to be stable and to be useful for production. We have quite a few packages already. There's a list there that I am not going to read through. And I want to stress that you can use this today if you want. If you have a running CentOS Stream 8 system, you can DNF install CentOS Release Hyperscale, and that will give you access to the repo where these packages are published. Now, let me deep dive on a couple of packages here. So the first one I want to talk about is systemd. This is an actively maintained backport of the latest systemd upstream release, which right now is 2.4.8. This is what we run in production at Facebook and what other companies also run in production. It tracks the latest stable release, and we use a repo to stage patches that go into here. The packaging is based on the ROI Fedora packaging with a few changes for compatibility. And as you can see, the packaging is maintained on a side branch on git.centos. In addition to this, we build daily snapshots of the latest Git master of systemd with a CI/CD pipeline. The idea here is that if there's any change upstream within systemd that is happening, we can find it quickly if it's going to cause issues downstream in CentOS and engage either with CentOS or with systemd as needed. With this pipeline is also used to keep the staging repo up to date. And we've published the scripts we use for doing this continuous build on Pagure, and we also publish the packages for these on CVS every day. So if you have a need to test the latest systemd Git master, you can find it there. Although obviously I do not recommend running that in production. Something else I've been working lately was a build of LLVM 12. Now, CentOS already ships with LLVM. It ships with LLVM 11 as part of the LLVM toolset module. Internally at Facebook, we had a need for 12. So what we did there was that we talked to the maintainers of LLVM in CentOS and found that they were planning to work on 12 for the next release, but their work wasn't quite ready yet. And in the meantime, I set on to building 12 within the community build system. We did a non-modular build because we can't do modular builds in CDS right now. And this worked pretty well. We were able to build LLVM 12 and the whole stack, so LLVM, Clang, LLDB, and so on. What is interesting about this process, and what I think makes it a really good example here, is that as part of this, we found a number of testing failures. So we engaged with the upstream maintainer and pointed out, hey, we found these testing failures. Is this something you are also encountering? Upstream pointed us to a patch that was being discussed within the LLVM community. We were able to apply this patch and test it, provide feedback that it actually fixed the issue, and iterate on it with the community. Long term, this will also make life easier on the Redis side, because when the Redis maintainers go and update LLVM there, they will be able to leverage the work we've done here. And of course, once we get LLVM 12 in CentOS proper, we'll drop the SIG build here. There's no need to keep a side build of this if it's going to get into the distribution itself. Now, in addition to backports, we also have a few packages where we do what we call policy changes. So I mentioned earlier in the talk that, for example, at Facebook, we run IP tables with the legacy backend. In practice, this means that we have an internal build of IP tables with this backend enabled. There's no need this has to be internal. So this is the example of something that we tried moving into the SIG, both to lower the burden of support for Facebook, but also to make it available to other companies and environments that might need this as well. Finally, we think the SIG can be a good place for large-scale testing of new features. I mentioned earlier that the work we're doing within Fedora around the DNF and RPM copy on write effort. This is something that requires patching the entirety of the packaging stack. It is definitely non-trivial to build and test if you want to do it. And it is something we are actively deploying in production at Facebook. So it makes sense for us to try and build this work in a public repo and publish it outside, both so that others can test and deploy it, but also to make it easier to validate that the change is actually sound. Because this is on production already, stuff is delivered into its own repo. And if you want to test it, you can DNF install CentOS release Hyperscale experimental. We hope to use this repo in the future to test other features of this type and scope. There's other work that is happening that isn't quite ready yet, but I want to talk about it. Something that has been of interest to several parties here has been the kernel. We would like to be able to publish an upstream, a kernel that is closer to upstream, ideally a kernel tracking in LTS version. Both because we think there is value into having a kernel closer to upstream that is usable by CentOS, but also to make it easier to test and deploy in production features that aren't enabled in distribution by default. So things like ButterFS, things like Sigurd2, a lot of the work that's recently been happening in BPF, these are all things that we're looking at enabling here. Specifically for ButterFS, there's work happening not just in the kernel, but in a lot of the user space tooling. To be able to use ButterFS, you need installer support, you need ButterFS progs, and to be able to use some of the advanced features like transactional updates, you need other user space enablement. We are hoping to eventually produce install media with all of these features enabled, so that if someone wants to deploy CentOS using ButterFS, they have an easy path to do that. Finally, in the cloud space, we've started building container images that have the Hyperscale repos already enabled and already shipped, for example, with our systemd build. And we're in the early forays of discussing how to build cloud images. All the work within the SIG is coordinated on Pagure, so if you're interested in seeing what's going on, you should have a look at the issue tracker there. All right. As I mentioned, I wanted to close with a few words on how you can participate. The CentOS community is an open source community like anybody else. You should read what's happening in the blog. You should join the mailing list and engage with developers there. You should attend a meeting. And this is probably one of the best ways you can engage with the community. Almost all of the SIGs have meetings, either on IRC or over video conference, where you can engage with people directly. And while we're still unavailable to meet in person for conferences, this is probably one of the easiest ways you can talk to people. And then, as I mentioned, you can join a SIG, or you can make your own SIG if none of the existing ones fit your need. You can file bugs on Bugzilla. You can maintain packages in EPEL, and you can also contribute to Fedora if the change you want to make is a better fit for that. And finally, as I mentioned, CentOS Stream is here already. So what you see on the side is a screenshot of the GitLab instance where CentOS Stream is being developed. The source repos for Stream aren't on git.centos, they're on GitLab. And you can see all the merge requests that are being applied in part by Red Hat engineers and in part by community members to build a new distribution. As of a while ago, composes are also available. So you can download an ISO image and install Stream 9 in a VM or wherever if you want to test it. So I would highly recommend you to have a look at this and see if there's a feature or a package that you have a particular interest in. Have a look at how it's set up. See if there's something you can do to make it better. See if something that you can do to make it work better for your use case, and engage with the community there. That's all I have. Thank you very much for listening. I would be happy to answer any questions you might have. I will leave with a few links here to previous talks and other resources we've given in this space. And thanks again.